In this video, I'm going to be asking you guys few set of questions. For all of that, you guys have to pause, think over what might be the answer, think with logic so that you learn the concept better. Okay, so all these questions are small, but it will help you revise the things which you have learned and it will help you understand things which you are learning. Right, guys? Okay, chalo, we'll start off now. We know that the apple is pulled down by the earth. That's why the apple falls. Right? Makes sense? Does the apple pull the earth? Is it an yes or a no? Yes, the answer is yes. The next question to you guys is justify why is it yes? How can you explain it? What law helps us explain this? I'll give you guys a clue. It has to do with Newton's law. Newton's, yes, third law will help us explain this. For every pull, there is one more pull in some sense. That is, for every action, there is an equal and opposite reaction. Right? So if this is the action, we can tell this is the reaction. Moving on, the next question is, then why don't we see earth falling towards the apple? We see that the apple fall towards the earth. Why not the other way around? Can you guys think of the answer? How can you explain this? See, okay, my explanation will be in two ways. One is I'll explain it with an experiment. I'll start off with an experiment and then explain with the logic. Okay, with this conclusion, I'll try to put it across so that it makes sense. I just don't want to give it in terms of a framed answer. I want to take it this way. So let's look into the experiment. So the procedure starts like this. Set up the experiment as shown in the picture. So this is a picture. So what do we have? We have a toy cart which is being pulled from both the ends by say mass m1 and mass m2. Clearly m2 is greater than m1. So what will happen? The body will accelerate towards the right. Make sense? It will accelerate towards the right or left. It should be left or right. Yes, it is right. Why right? Now try to recall why is it towards the right, not to the left. Yes, because the net force is to the right. Okay, so this should be your explanation. This is as per which law? Is it as per Newton's first law, second law, third law? This is as per Newton's, yes, second law. Okay, again, I hope you guys are answering all the small questions I'm asking. I would like you guys to pause and think over whenever I ask. Okay, chalo, let's move on. Now let's go. Let go of the mass. So what I mean is, I'll generally, not generally. This is how I do. I hold the system. I switch on everything. I hold the system, and after a second or two, I let go of it, so that we can see the motion. So I let go of the mass and observe the velocity, acceleration at the end of the table. So this is done by sensors. Okay, so I have set of sensors which will help me calculate the velocity and acceleration. So basically you guys have to take a pen and paper and make a note of whatever is the value that is shown in your display. Okay, so you're going to have two experiments being done. So the variation is this. In the second experiment, in the second setup, we'll add more mass on the toy car. So we're going to add say one or two more set of masses, and we need to make a note of velocity and acceleration in that case too. Got it? Simple. All you have to do is have a look at it. Look at the toy car. Look at the masses in both the experiments. They remain the same. They are not going to change. The mass on the toy car is going to change. And each of this case, you need to have a look at velocity and acceleration. And now have a look at this video. I hope you guys made your observation and took a pen and paper and wrote it down. All this is, discipline. Of course, even I have the value. I'm going to write it on the screen, but you guys have to be disciplined too. No such thing, doing an experiment is a discipline. It's just not something which you can do it at that moment. There are a lot of small things that you need to learn. So learn step by step. Okay, so in the first case, the velocity was 1.16 and the acceleration was 1.9 meter per second and meter per second square. Always do write the units. If not, it won't make sense. This is approximately 1 meter per second and this is 1.4 meter per second square. This for your velocity and acceleration in the first and the second cases. In the first and the second case. Okay, what is that we can conclude? See, this case was, I have not mentioned it. This was for lighter mass, is it not? The car was lighter compared to this. This was heavier. This was higher. This was heavier. The mass over here was high compared to this. So as in when we increase the mass, what is happening to the velocity and acceleration? Of course, it's common sense. The velocity and the acceleration will decrease. That's why when you're going uphill, if you guys have seen heavy, huge buses, carrying a lot of people. If by chance, if they are old buses, what they do is they ask the people to, walk till the end of the uphill. So all the people generally they walk and wait over here while the bus driver aram se gets the vehicle. That used to happen a lot before. Now the frequency would have been reduced, but old buses, if you guys see, this will continue to happen. Why? Because when you decrease the load, that is the number of people and the things inside the bus, it will have more acceleration and velocity, so it will be able to climb that uphill. Right? Okay, let's conclude. For a constant net force, see, we're not increasing or decreasing all of these masses. So the net force will remain the same. For a constant net force, the velocity and acceleration of an object reduces or increases as we increase the mass. Yes, it will reduce. Is it not? It will reduce. Right? Okay. With this understanding, we'll try to relate it to the question, why won't the earth get pulled by the apple? Well, actually it does get pulled by the apple. Why don't it fall towards it? So a small note which will help us make us understand this. Mass of the earth is 6 into 10 to the power of 24. That is 6 followed by 24 zeros. While our apple, the average mass of an apple is 200 grams, that is 0.2 kg. Right? Compare this. You can see that there is such a huge difference. Is it not? By a factor of 10 to the power of 25. 3 into 10 to the power of 25. Earth is almost 3 into 10 to the power of 25 times in mass bigger than that of an apple. So what will happen? Let me explain it with the experiment. Say before that, I have to talk about Newton's third law once more. What does it tell? If I have an object, say an apple, and the other object is earth, and if the earth is pulling the apple with some force, the earth also will get pulled by the apple with the same force. So the force is same, right? Remember, this is fixed. The amount of force is fixed. Okay, so let's imagine this weight represents the force. Now, say this toy car it does not have any mass of its own. So on this, I'm going to keep the apple. Okay, imagine that I'm keeping the apple over here. If I let go, what happens? It will move. Now imagine for the same force, you happen to keep the earth itself. Of course, it's not practical. It doesn't make sense, but still. Okay, think of keeping an object which is equal to that of Earth's mass. There's a object which only Superman can lift or something. It's of huge density, and this small piece is equal to that of the mass of the Earth. Again, it's not practical, but again, I'm just making up a question. So we happen to keep it on this. What happens? Will this be able to pull this force? Or forget about that. Say we happen to keep a car. Or say you happen to sit on this toy car. Will this force be able to pull you? Obviously not, right? There is a force acting. That is true. But it won't be able to pull. Forget about Earth if you guys only sit. Or if you guys keep just a finger. Finger, I guess it can pull. But say you guys sit. Even then, it won't be able to come down. This won't be able to come down, or this won't be able to move forward. So think about this scenario. That's why we don't see Earth falling towards the apple. But yes, there is a force exerted by the apple on the Earth. That is there. That's explained by yes, Newton's third law. Okay, I hope you guys were able to learn a lot of concept, revise a lot of concept with this set of questions and everything. So I have a small conclusion. The mass of the apple is negligibly small compared to that of the Earth. So we don't see the Earth moving towards the apple. So this is your written answer. What can we conclude? Very important conclusion. Okay, this is the combination of the last chapter and this chapter. All objects in the universe attract each other. True. It's the acceleration that varies. What does that mean? See, we know that force is fixed in both these cases. And as per Newton's second law, what does the second law tell? What is the formula that it gives? Yes, acceleration is equal to mass by force, right? Wrong. Force by mass. Is this correct or was that correct? Yes, this is correct. So if the force is fixed, if the mass is huge, not downward side, huge, really huge, what will happen to acceleration? It will reduce a lot, right? It will almost become zero. All objects in the universe attract each other because of gravity. Is the acceleration that will vary, is it not? This force of attraction between objects is called as gravitational force. Okay, it's a simple definition of gravitational force. Right guys, I hope you guys enjoyed this video and we revised a lot of things and a lot of concept will make sense to you guys from now onwards. A lot of documentaries will make sense, right? A lot of discussion will make sense. A lot of outer space missions will make sense. There are a lot of things that we will discuss which will help you guys understand so many Mars mission. And we have Elon Musk talking about sending a mission. We have rockets which will be used to go and come back. So there are practical questions like how will we have enough fuel to come back? And taking off is a big deal. You guys can see takeoffs of satellites, of missions. There's a huge fireball that comes out. That is, we are burning a lot of petrol. So how is that we'll be managing the same launch on the Mars, right? So such practical questions are there. If you want to understand, this chapter will help you guys understand. It's not too difficult. Such question to be answered, it's not too difficult. Of course, the answers are difficult. Asking such questions and understanding such questions, it's easy. That's what I mean to tell. So first thing is you should learn to ask good questions. I mean, that's most difficult part, right? Okay, anyways, let me not waste too much of time. There are a lot of things to discuss. Let me put it across the chapter. So now I want you guys to pause and try to write as much as possible. As usual, this practical section, I want you guys to just write a running note, especially the diagram, and a small note for yourself. Try to write all of this question and make your own running note. Okay, this too. And this too. The conclusion and this part is important.